The sun is the dominant object in our sky. Actually, it's the dominant object of our entire solar system. The sun keeps all of the planets in orbit, and its light provides all the warmth that the Earth needs for life to survive. In fact, there wouldn't even be a solar system without the sun. But what is the sun made of exactly? Why is it so hot? And how can studying a lava lamp help us better understand how the sun works? Put simply, the sun is a star. But unlike all the other stars in the universe, the sun sits in our own backyard, about 93 million miles from Earth, which sounds really far away, but the next closest star is 600,000 times further. The sun is so massive that 93 million miles is plenty close enough to keep us warm, and if you're anything like me, it can easily give you a sunburn. For a sense of scale, the sun is 109 Earths in diameter. And get this, 1 million Earths can fit inside it. If you were to gather up all the stuff in the solar system, the sun, the planets, the random gases, the asteroids and comets, all the moons, everything in your junk drawer, the sun would make up 99.86% of all that stuff. The sun basically is the solar system. Actually, let's think about that name for a moment, solar system. Well, in Latin, the sun is called Sol, which is the ancient Roman god of the sun. Solar means literally of the sun. The sun kind of runs this place. So if we slice the sun in half, you can see that there are several layers to it, kind of like a cake or an onion. Let's start in the center, the sun's core. The core is the innermost part of the sun, and it's a nuclear reactor. We're going to talk about that in a minute, but the sun's energy is produced here. It's also the hottest part of the sun at 27 million degrees Fahrenheit. The radiative zone is where particles of light called photons transfer heat from the core out to the other layers. It can take light thousands of years of bouncing around in the radiative zone before it can finally escape to outer space. Before we go any further, we need to talk about something called plasma. You probably know about the three main states of matter. Something can be a solid, a liquid, or a gas, but there's a fourth state we don't talk about as much called plasma. All of the hydrogen and helium inside the sun is in the plasma state. It's like a gas, but it can flow like a liquid. Okay, back to the layers of the sun. Next is the convective zone. Here, the columns of plasma rise and fall as they heat up and cool down from the radiation of the sun's core. And this is where a lava lamp can actually teach us a lot about how the sun works. The light bulb in the bottom of the lava lamp is a lot like the sun's core, producing light and heat. The wax in this lamp is like the plasma in the sun. As the wax heats up from the bulb, it becomes very fluid-like, and it rises to the top of the lamp. Over time, the wax at the top begins to cool before it falls back to the bulb where it will warm up again. Now let's compare this cycle to what happens in the sun. Plasma heats up from the core and rises to the sun's surface. Here, the radiation and light can leave the sun, and the plasma cools off, just like the lava lamp wax, and it falls back down to the core to heat up again. This cycle creates massive columns of plasma rising and falling inside the sun. The very top of these columns is called granules. Every little spot that we see on the sun is the top of one of these massive columns, a granule. A granule may look tiny in this picture, but remember the sun is gigantic. Those granules can be as large as the United States. As we near the top of the sun, we've reached the atmosphere, or the photosphere. This is where the light finally leaves the sun to travel into the solar system. Here we find the solar winds, the massive corona, which you can see during a solar eclipse, and even, get this, superheated plasma tornadoes. The average temperature here is 10,000 degrees Fahrenheit. But what creates all that light and heat inside the sun? Nuclear fusion. Let's go back to the sun's core. Here in the core, there's over 1 million miles of hydrogen crushing down from all directions. This creates enormously high pressure, so great that it crushes the individual atoms into each other. 4 hydrogen atoms are compressed so hard they fuse to create a new element, a helium atom. In the process, some of that mass is converted into energy in the form of light. In 1 second, it fuses 600 million metric tons of hydrogen into helium. In just 1 second, the energy from the sunlight is 10,000 times more than all the power used by humankind in history. It's the reason that some people hope to efficiently harness that light to produce electricity through solar energy. The sun releases an insane amount of energy if only we could harness it. Like other main sequence stars, the sun is a balancing act between gravity and nuclear energy. The gravity of all that hydrogen and helium is crushing inward, trying to pull the sun together, and the nuclear energy is trying to push everything outward towards space. For as long as the sun has enough hydrogen to fuse into helium, it'll stay perfectly balanced. So that's our sun. To be honest, we've barely scratched the surface. We haven't touched on solar flares, the sun's magnetic field, the sun's gravity, weather, or the instruments that scientists use to study the sun, like the Parker Solar Probe. Those are going to be topics for another day. But for now, when you look up at the massive bright orb in the sky, you'll know a little bit more about the most powerful object in the solar system.
1, 2, 3, 4, 5, 4, 3, 2, 1, 1, 2, 3.